Hi everyone, very good evening and welcome back to Geeks for Geeks practice. Guys, please give me a +1 in the chat and hit the like button if you can clearly hear my voice and everything is working fine. Hi to Rishit as well as always. So let me share my screen and then we'll discuss the problem of the day for yesterday. That was quick sort, which is obviously a very popular sorting algorithm that we must have studied in our first year or second year. Now I will share my screen and then we'll discuss this algorithm as well. I think that is why the attendance is a bit low because this is a very popular algorithm. Okay, so let's do one thing. Let me just open this and then let's discuss. Okay, so in this particular question, what we have to do is we have to implement the functions of the quick sort algorithm, right? Now, what is quick sort? Hi, Amar Sai. So basically, we have to implement the quick sort algorithm, right? And the quick sort algorithm is asked in a lot of companies. And before moving forward, also, there is one thing that I want to show you that the problem of the day July placement special. So all the problem of the day in the month of July are popular interview question. So solve every question to get updated to do well in the placement season, because every problem that is asked, it in the POTD this month July, it has been asked in some company or the other. So please make sure to do the problem of the day regularly in this month. Okay, because you can see quick sort also has been asked in a lot of companies here. Now, what does the quick sort algorithm say? Okay, so suppose that if I have to sort the elements, if I have been given some elements and I have to sort them, so what is the philosophy of quick sort in that case? So basically the quick sort says that if we have to sort, so there is one way. Suppose that you are having some students. Okay, suppose that you have the height of the students. Okay, you are having the height of every student. So suppose that someone is upper height, lesser height, and things like that. Okay, so if you want, if you are having an assembly in the morning, right? If you are having an assembly in the morning, so what will happen? Either the teacher can arrange the students one by one, but it will be very tedious task. Or what you do is, if you must have attended the assembly in your college morning assembly, then what happens is the student can arrange itself, right? The student can arrange it itself. Is that clear? Right? Student can arrange itself. So student can arrange itself. Now what does this mean? Arrange, just a second. Student can arrange itself. Now what does it mean when I say that student can arrange itself? So basically this indicates that if a student can arrange itself, so basically suppose we are at this student, so this student can allow itself to stand at a position where all the students in the front are less than this student, are having height less height than this student in the front, and then all the student in the back, they are having higher height. They might be sorted or not sorted, but the idea is that if this student is selected as the pivot guy, then all the students after it should be lesser than this student's height, and we will try to see and arrange that all the students after this student should be higher than the height of the pivot student that I have chosen. Is this part clear to everyone? Please write yes or no in the chat. This is the main crux of the sorting algorithm. Okay, quick sort algorithm. What we do is we basically choose a guy, and suppose that we have to arrange in terms of assembly, if we have to arrange the students. So what we can do is a student can choose it, like a student can be there, and with respect to that student, all the people who are lesser, all the students that are lesser than it, they will come in front. They might be sorted or unsorted, but all the students who are lesser in height, they will come in the front, and all the students who are greater in height, they will come at the back. Is this part clear to everyone? Please let me know, guys. Is this much very basic thing clear to all of you or not? Please let me know. Is this part clear? Rishit and everybody, you can just let me know and hit the like button if you are clear with this point. This is the most important point. Okay, Rishit says clear. Others can also tell me whether they are clear or not. Okay, so basically, suppose that you have some elements. Okay, so what you will do is, suppose you had an element 10. So what you will do is you have this element 10. So in front of it, all the elements you will try that they are lesser than it. Okay, they can be in any order. You don't care in which order they will be present. Okay, but they can be in any order, and you are fine with that. Okay, as long as they are lesser. So you can place 3 here and 7 here. and then you will try to place all the other elements in such a way that on the right side of the pivot element of this element, such that they are greater than it. So it can be 12 here, then we can have 18, then we can have something like 16. So all the elements on the greater which are greater, they will come here. So this is the basic idea, that every student will try to do this thing, and then in the end the things get sorted. So basically, when we have an initial search space now, let's say we have an initial search space, so let's say you have a low and you have a high initially. So let's say we will choose a particular pivot, and with respect to, we'll choose a particular pivot, and we will try to sort things in such a way that after sorting, what happens, the guy comes in such a way that all the elements, all the lesser guys are in the front, lesser elements on the high, all the higher elements are at the back. Okay, and then again you will break down this particular search space, because this guy is at its place, right? Then this will be the low, this will be the new high, and this will be another low, this will be the another high, because now you will do what, you will try to rearrange this much elements, all these elements and all these elements. So you'll try to sort them. Is this part clear? The basic idea is clear, why we have to consider for low and high and all that. Because what we will do is we will choose any pivot element. So let's say maybe you can choose the highest this element as the pivot, right? And then what you will do is, after applying the approach, you have to make sure that this element is standing at the place where all the elements in the front are lesser and at the back are higher, so that this guy is, at least we can say that this guy is placed. And then we break again, so we break this first half from low till high, that is just before this, and then another half low till high, and then we call the functions again. So is this idea clear to everyone? Because this is very important. This is the main crux of the quick sort algorithm. Is this much part clear, guys? Then I will proceed further how to place a particular guy at a particular place. Okay, like how to get the perfect position. Okay, Rishit is clear. What about others? Others also can tell me. Marsai, what about you and other people? You can tell me, guys. Okay, so I hope that this much point is clear. Now let's take an example. Okay, so here you can see that we have two functions. Okay, we have the quick sort function, and then we have the partition function. Okay, so partition, in the partition function, what we will do is, Pragya is also clear. Thanks a lot, Pragya. So you can see here we have the quick sort function. So in this case, what we will do is, with we will have the low and high, and in the partition function we will be doing what, we'll be checking for the position of the pivot. So I'll tell you how this will happen. Okay, so in this particular case, let's take a sample array, and you can help me out in rearranging the elements. Okay, so suppose that I will take the elements one by one, which I have written here. So let's say I'll take the element as 10, then I will take the element as 16, then I'll take 8, then let's say I'll take 12, then I'll take 15 also, then I'll take 6, then let's say I'll take 3, then I'll take 9, and I think this is fine. Yeah, so then after this, what I will do is, let's say I can choose any element as the pivot element. So suppose that if in this case, suppose that I will choose this particular element as the pivot element. Okay, suppose that I will choose this particular element as the pivot element. Okay, so in that case, I want what, I want to place 9 in such a way that all the elements lesser will come in front and all the elements greater will come at the back side. Okay, so understand this thing, how it is going to happen. Okay, so is this much part clear, guys? Okay, so I'm considering, let's say this is the low. Okay, and this was the high. So initially I've considered the high element as the pivot element, and then what I will do is, I will have a variable. So let's say I can have a variable, let's say L here. So it will be standing here, and what I can do is, at the same time I can have let's say I will have L here, or I can have I here, let's say L here, and I have the J standing somewhere here. Okay, so in because see, if I have this thing, so just a second, since I've chosen high as the pivot, so let me choose this as I, and this is I, and I will be running from here till this point. Okay, so now I will be changing whenever the requirement is there. Okay, so what I will do now is, I will have a check. Okay, so you can understand one thing, that now I will check. So this is the current ith element. So is this element lesser than the pivot? No, it is not less than the pivot. Okay, so since this element is not less than the pivot, then I will move my I forward. Okay, so I will do what, let's say I will move my I somewhere here. So let's say my I moves here. Now in this case, suppose if I'm checking now, so if the element okay, so if I am checking this thing, just a second. So maybe if I'm checking, so I can also do one thing. If I have a pivot element, so after it the elements can be higher also, and before it the elements can be lower also. That can also be possible. So in this case, what we can do here is like either of the things is fine, but let's see. So if I have I here and the ith element suppose is greater, so if the ith element is greater, then again I'll not do anything. Then after that, suppose I come to this place, and when I'm at this particular place, so then I can see that this ith element that I have chosen, it is lesser than the pivot. Okay, so since this element is lesser than the pivot, so I want to have it at the starting. Okay, so I'll replace it with this guy. Okay, I'll swap this L and ith element. So what will happen basically here is now from here at this place we'll have 10, and at this place we'll get 8. Okay, understand this thing. And then I will move my L forward, so L will come here. Let's say L will start coming here, and then my I will come here. So now I will check, is this ith element lesser? No, it is not lesser. So in that case I'll move forward, and then we move here. So is this ith element lesser? No. So then we'll move forward and we will move here. So is this ith element lesser than the pivot element? Yes. So in that case, we'll swap this and this. So here we will have 6 and here we'll have 16. And then L and R will move by 1. So L moves here and I will move here. So, sorry, I will move here. Yeah. Now, if I check again, so yes, the ith element is lesser than the pivot. So in that case, I'll swap L and L because L is standing at a higher element. So I'll swap this. So what will happen here is at this place, just a second. I was having 10 here, and what was I having here? Yeah. So I'll have 3 here now, and I will have 10 here. All right. Then after this, what we will do is we will like our I loop will end because I has to run lesser than I. So I will end here, and L will move here. Okay. So L will move by 1 step. So L will come here. Now after this, what we will do is we'll swap the like we will swap this pivot element with this element. Okay, so understand, now I'm swapping the pivot element with the with this element with the L that is standing here. So now when I'll swap these two, so what will happen, at this particular place I'll start having 9, and at this particular place instead of 9 I'll start having 12. So can you see one thing, guys, that after this, what has happened is, if you see, so we have 8, then we have 6, then we have 3, and after that you can see in between we have 9, that was the pivot earlier, and then we have 15, 16, 10 and 12. So you can see that since I chose 12 as the pivot element, so all the elements that are before 12, that are lesser than it, okay, that are lesser than it, they are not in the sorted order, that is fine, but they are lesser. And all the elements after this 9, that is the pivot element, they are higher than it. So we can say that in the assembly 9 has arranged itself at its place. Okay, 9 is at its place because 9 is standing at a place where all the elements that are in front of it, they are lesser, and all the elements after it, they are greater. Is this part clear to everyone, guys? Please let me know till now. Rishit and everybody, is that clear to all of you? Till now, is this point clear? So this is how we run this particular approach of finding the right place for the pivot element. Okay, so find like placing the pivot element at the correct place, placing the pivot element at the correct place. Okay, at the correct place. Okay, so this is what we do in the partition function. Is this much part clear to everyone or not? Please tell me. If you are not clear, I can still do a dry run again if you want, but I hope that this much part must be very much clear to everybody, right, guys? Let me know, is my voice clear? If you are not clear, I can Rishit, Pragya and everybody can tell me. I hope that this much point is very much clear to everybody, right? Okay, so is this clear? Then again you can see what will happen is you will now break, so this much part will be rearranged and this much part will be rearranged. So that is how you will do. Until when are you going to do it? Until when? Until the low is less than the high. Why until the low is less than the high? Because for doing the quick sort, at least 2 elements should be there, no? At least 2 elements should be there. Okay, so that is why there is one partition function and there is one quick sort function, because what we do is we basically find the pivot. So once the pivot has been arranged now, then we will break into the first half, so we'll call the quick sort for this part. Okay, and then again we will call the quick sort for the other part also which is higher, so we'll call this quick sort here. So this is how the quick sort works, and you can see since it is divide and conquer now, so always what happens when you have an array, so whatever is the pivot element, you place the pivot element at its correct position, and then you divide the array into two halves, into the first half and the second half. So always you focus on the divisions, right? And then this part also gets divided into two halves, right? So whenever you are dividing into two halves, can you divide low is less than the high condition? Yes. So basically, Rishit, tell me one thing. Suppose that low is equal to the high. Okay. If the low is equal to the high, then only one element is there. Then do you need to have the pivot and arrange? No, because single element itself is arranged, right? So when should you apply the quick sort? You should apply the quick sort when the low is less than the high. Now, when at least two elements are there. Correct. At least when at least two elements are there, because see, if the low will be equal to the high, then in that case you don't want to apply, because a single element is itself sorted at its place. But if you have low is less than high, so this means at least two elements are there in the space, right? When suppose low is here, high is here, just adjacent to each other, and this element is let's say 5, this element is 4. So in that case you can apply the quick sort, right? At least you should have two elements, so that is why the low is less than the high condition. So that is when you can apply. So you can see basically what happens. This is a divide and conquer condition, and when you will have a normal array, then you will find for the pivot element you will find its position. Then after that you will break. So this will be the this part you will break, and then this part you will break. So that is one thing that is going to happen. Okay. So this will be the very first thing, and then I will be implementing the other one. So as I said, when will the quick sort happen? Just a second. I hope that this point is very much clear. Okay, guys, so just give me 1 second. Okay, so yeah, what I will do here is I will say that if it happens that the low is less than the high, because I just have to implement these functions. So if the low is less than the high, in that case only I will implement, because at least two elements should be there. Okay, then what I will do is I will say that okay, pivot, like if I have the pivot, so let's say after this guy is settled now. So if you will see here, after I chose the pivot element, so you can see here when I chose the pivot element as the last element now, suppose I was choosing. So after this, this will be the pivot index, right? Are you getting? After when I chose the highest element as the pivot element, and it got placed at this particular place, so this will be the pivot index. And after this, what I will do, from low till pivot index minus 1, I will sort, and pivot index plus 1, pivot index plus 1 till high, I will apply the quick sort. Are you getting? So that is why what I can have is, let's say I will have the pivot index. So after the process is happened, then where is the pivot element standing? That is what we need to do. So for that we will call the partition function. So partition. So this basically this function does what? It will tell me what is the correct position of the pivot element. Okay. So that based on that I will call based on this pivot index. So from low to pivot index minus 1, I will call the quick sort, and from pivot index plus 1 till high I will be calling it. Okay. So in that I will pass the array, I'll pass the low, and I'll pass the high. So this will basically place the pivot element. In this case I'm choosing high as the pivot element, so it will place the pivot element correctly, and I will get the pivot index also. Then after this particular thing is done, so after this after it will be get placed now, so then I will call the quick sort function. Okay. So then I will call the quick sort function, and in the quick sort function I'll be passing the array, and the low range will be low here, and the higher range will be what? Pivot index minus 1 for the left guy, right? Pivot index minus 1. Is this clear to Rishit and others also? Then after that I will call the quick sort. So let's say I'll call the quick sort here, and then what I will do is I'll pass the array. Then what will be the lowest range? So the lowest will be pivot index plus 1, that is just ahead of the pivot index. And after that, where pivot index is the the correct index of the pivot element, before which all the elements are lesser, and after which all the elements are greater. So pivot element is standing at the correct position, and then I'll pass the high here. Okay. So this is what we need to do in this quick sort function. After this, what we need to do is we need to implement the partition function. So in the partition function, as I already told you, we will take a pivot element. So like we will take a pivot index. So let's say we'll take it as high. Okay. Then after that, what I can do is, as I already told you, that initially, let's say I'll mark my L as low, that I did for the dry run. And then what I will do is I'll say that okay, while int I will start from low, and I is less than the high. Why I is less than the high? Because I don't want to run till the pivot index, since I have considered the high as the pivot index. Okay, then after that, what I will do is, if it happens that array of I, if it is lesser than the pivot okay, if it is lesser than the pivot, so in that case I want this element to go in the starting. If the ith element is lesser than the pivot, so I want this particular ith element to go in the starting part. So that is why I will swap it with what? I will swap it with a of l, which is standing at the low. So let me write arr of l, in fact, and comma, I will write what? Comma arr of I. So I will swap these two, and then after that I will increase the L value, because I'll move to the next cell, as I already told you. And once this is done one by one, then at the very end, what was I doing? As I told you, I was swapping at the very end. I was swapping what? I was swapping ARR of L with what? With the pivot element. Okay. So with ARR of pivot, you can say PIVOT. I was swapping them, and then at the end I will just return the pivot index, and that will be nothing but, you can return L here, because that is the pivot index. So I'm swapping L with the pivot. Is that fine? Yeah, that is fine, right? So yeah, this is how it will happen, and let's now try and compile it to check if it is working or not. Is it clear to Rishit and everyone else who is present in the chat? Guys, let me know. So yeah, this is working. Let's see. It works fine on the samples. So this is how it will keep on breaking. But I hope that the actual basic logic is clear to everybody, right? Yes or no, guys? Okay. Now I will try to submit this code, and obviously it should get submitted because it was an easy one. All right, you can see that this code gets accepted here, right? So yeah, this is how we do it. Basically, we find the pivot index, and it will be L. So I'm returning L here at the end, and I'm placing the pivot element at the correct place, because I'm swapping the A of pivot with A of L. Is that clear? Online, there are many ways of selecting the pivot in each round, like select first or the last as the pivot. Do we need to know all the methods, or a few of them are enough? So either you can choose the first, like my preference is either I choose the higher last element, or the first one. So like either I choose the low as the pivot or high as the pivot. So that is my idea. If you want to use anything else, that is also fine, but normally it is fine. Like either you choose the high or the low. That in that case, the if you are going to explain in an interview, so this will be better, no? So that is why I either choose the highest index or the lowest index as the pivot. So in this case, I have chosen the highest as the pivot index, and it will keep on doing. So since you can see now, it is dividing like you divide in the merge sort function also, right? In the merge sort algorithm. So basically, you are dividing here again and again, and this is nothing but what you are calling recursion. Okay, so you are calling recursion again and again. So you are dividing the array into two halves, because if you here the size was n, then after that the size becomes n by 2 n by 2, right? Like this, n by 2 n by 2. So it keeps on doing until you reach 1. So whenever you are dividing by 2, then n by 4 and n by 8, like this. So whenever you are dividing like this, so actually what happens in this case, you can say that the complexity, like the space complexity taken for the recursive functions that will pile up over each other, will be log of n, order of log n. This will be the recursive stack space, no? Recursive stack space. And the time complexity, stack space. And what will be the time complexity? The time complexity will be nothing but order of n log n here. Okay, because you are dividing n log n, and n elements initially were there. So overall, you can understand this will be n log n in nature, right? So is this clear to everyone, guys? Yes or no? How did we partition, and after partitioning we found that pivot index, so we are returning this L, that is the pivot index. And once we return it, so based on that, the left side is lesser, okay, and right side is having greater elements. So I will now apply the quick sort on this and this. And for applying, the basic condition is that at least I need to have two elements. So that is why low is less than high, because if low is equal to high, so there is no point of applying quick sort, because if only one element is there, so it will arrange. So at least two elements should be there. And the idea is that in an assembly, if you ask the student to arrange themselves, so if every student stands at their particular correct position, then automatically the assembly line will be in sorted order. So this is how it works. I hope that you are clear. Is the worst case complexity order of n square? Yes, I think so, that the worst case is order of n square. I'll just check. Worst case complexity of quick sort. I think it is order of n square only, but I'm just checking it again. So yeah, no, it says best is this much, but what is the worst case? WOR. Still, let me write WOR. Okay, I think it is n square only. Yeah, it is n square in the worst case, but that will happen only when you are kind of when your pivot has been chosen in the wrong way now. So what might happen is you might you what might happen is, suppose that if you are choosing high, okay. So suppose that what you have is you have an array maybe something like this 1 3 5 7 9, and then you choose this as the pivot, right? So this will be the worst case. Why? Because see, when you choose this as the pivot, and right, you have low and high, then you choose this guy as the pivot. Then what happens is, after applying the partition, you see that okay, this guy's place is here only, right? So in that case, what happens now when you will sort? So now the for which array will you call? So you'll call for this array now 1 3 5 7. So you can see that actually it is not getting divided into two halves now. Earlier when we had chosen, so it was getting divided into two equal halves. So that is the best possible scenario. But in this case, again, when you will choose, so again, if you are choosing the last element as the pivot, so you choose this guy. Then again, say, like after that, you will call for. Then you will see that okay, still 7 will still stay here. So you'll call for 1 3 and 5 like this. So this will be kind of linear. So that is the problem. Are you getting? So that is why the worst case would be something like that when you choose the pivot. So that is why they have a lot of ways of choosing the pivot, because the best thing is that if you choose the pivot randomly, so that is better, because if the array is sorted, then in that case choosing low or high can make difficulty, because in the worst case it will be order of n square. But yeah, this is the case. So I hope that I have explained this case also when you have the order of n square complexity, because it will be kind of linear only now. So that is why the distribution you can see that you are doing it is this only. So it's not going to work for you. Is that clear to everyone, guys? So it will break down to order of n steps, right? Because you are not breaking into two halves. So the thing is not going to work here. Okay, others can tell me, Rishit, is that clear? The worst case complexity is how it is order of n square. Is that clear to everyone? Because if you don't choose the pivot correctly, so that is how it is going to create an issue. And if you talk about the company, so it has been asked in Amazon, VMware, Microsoft, Hike. So it is just that don't mug up. Okay, don't try to. What I want to say is, let me just remove the screen from here. What I want to basically, what I want to convey here is that when you are solving the quick sort, so please give me +1. I was also very afraid when I started with quick sort or merge sort. But the thing is, understand what is the basic logic or what is the basic ideology of that algorithm. And then you are never going to forget it. Like for quick sort, you can say when somebody itself, what is quick sort? So in an assembly line, people very quickly in the morning assembly, students very quickly rearrange themselves. How? So that is why it is known as quick sort, because they see that I should like all the people who are lesser than me, they should be ahead, and all the people who are greater than me, doesn't matter whether they are sorted or not, they should be behind me, right? So that is how this works. And if you understand the core concept of it, so it is not that you have to remember the code and the basic condition that why low is less than high, because at least you need to have two elements for doing the quick sort. Because if you have one element, so that is already sorted, right? That is already at its place. So that is why low is less than high. Then you have an idea of choosing the pivot, and the idea will be that the pivot element will be placed at the correct position, and then we'll get the pivot index, that is the updated index of the pivot element. And in front of that, all the elements will be lesser, and at the back of it, all the elements will be higher. And then after that, you will call the partition, you will call the quick sort again from low to pivot index -1, and from pivot index +1 till high into two parts. So you keep on breaking, that is divide and conquer algorithm, divide and conquer approach. And that is why you will keep on breaking. So the recursive stack space will be order of log n, that will be the space complexity. And since you are breaking into this many parts, so the complexity will be n log n also. So this is what you need to remember. And then in the partition function, you just need to do what? You just need to place the pivot element at the correct position. So if you choose the high or the low, so this is how it works. And that is why there is a reason why these companies ask these questions, just to, in order to check whether your basics are clear or not. Okay, guys. So you can see that is why this problem. And as you can see in July, you can understand one thing, that in July what happens is a lot of every question that is there, it has been asked in some company or the other. You can see here it is mentioned that placement season is coming. So all the POTD in the month of July are based on popular interview questions. So solve every day to ace the upcoming session, and then you can click on register. So I have already registered, so it is not showing, but you can click on the registered part. Okay. And yeah, as I already told you that the time and the space complexity is fine. Then it has been asked in HSBC Bank, Grofers also asked it, now Blinkit, Target is also a good company, Adobe, Goldman Sachs, Ola, Hike, Samsung. So a lot of good companies have asked it. Now I'll just provide the code also. Just give me a second. And please hit the like button, guys, if you are very much clear with this. Okay, I'll be very, uh, like you can say, happy. Okay, I hope that you did understood everything inside out in terms of logical side of things, because uh, you can do the partition for the rest of the part. Main thing is that whether you understand the crux of it or not. Okay. Thanks a lot, Kanishk Kashyap. Okay. So I'm copying this and sharing it. If I'll do it for the whole arena, so it will take a lot of time and unnecessary time. If you understand the whole logic, then that is fine. Because in the interview also, you just have to do one trial, and the interviewer will understand that yes, you have a clear understanding of the quicksort. So make sure to try this problem out if you haven't, and it was a very interesting problem. And I will see you next week, guys. Till then, keep coding, keep solving the problem of the day, and all the very best, guys. Thanks a lot.